Hi everybody, we're talking about determinants in this screencast. I want you to learn how to evaluate determinants of square matrices, and I want you to learn how to use the Cramer's rule to solve systems of equations. So let's get started. The first thing we need to understand is that a determinant is a real number, and a determinant is a number associated with a square matrix. Now, if we have a 2 by 2 matrix, how you figure out the determinant is you multiply the diagonals. So A times D, and then we're going to subtract B times C. Here's an example. So for matrix A, to find the determinant, we're going to multiply 3 times 1 and subtract negative 2 times 4. 3 times 1 minus negative 2 times 4. The notation for determinant looks like this. So the determinant of A is equal to 11 because it's 3 plus 8. Okay, now when we have a 3 by 3 system, it gets a little bit more complicated. You can read your book about cofactors and minors and majors, but an easy way to find the determinant of a 3 by 3 matrix is to follow this process. We're going to multiply on the diagonals, but notice what we have to do when we have a 3 by 3 matrix is take the first two columns of that matrix and write them right next to our matrix, kind of like we're making an augmented matrix. And then we're going to multiply on the diagonal. Everything you multiply on the diagonal that goes from left to right, you're going to add. And then the diagonals that go from bottom to top, we got top to bottom, left to right, and bottom to top. And the ones that we go from bottom to top, we are going to subtract. It's best to look at an example. So here's a 3 by 3 matrix. If I want to find the determinant, first I'm going to augment it with the first two columns of matrix A, and then I'm going to multiply on the diagonals. So I'm going to do 1 times 2 plus negative 2 times negative 1 times 4 plus 3 times 2 times negative 1. And then I'm going to subtract 4 times 1 times 3, subtract negative 1 times negative 1 times 1, and subtract 2 times 2 times negative 2. And so the answer is negative 1. Okay. You're going to want to know this method. It's going to help you. I know that you can do these on your calculator. I should show that to you. But I didn't put my calculator up here, but you can find the determinant on your calculator. You can see it, put the matrix in there, and click on the math key and look for DET, that stands for determinant. If I have time, I'll make a screencast for that. But doing it by hand isn't that difficult. And there's going to be questions on your test and on your final where you have to do it by hand. Your calculator is not going to work. So you have to know how to do this by hand. Because if you are asked to find the determinant of something like this, this is not something you can put in your calculator. So we can augment it with the first two columns. And then remember, add the diagonals going from top to bottom, and subtract the diagonals going from bottom to top. Pause the screencast. See if you can get the next line. Does yours look like this? X times 1 plus 1 times x times 0 plus negative 1 times x squared times x. And then subtract 0 times x times negative 1, x times x, and 1 times x squared times 1. Now if you simplify this, that's x squared plus 0 plus negative x cubed minus 0 minus x cubed minus x squared. The x squareds cancel, and so we're left with negative 2x cubed. All right, the next thing we need to learn about is the Cramer's rule. Okay, here's what Cramer's rule looks like. It looks confusing, but it's really not that hard to do. So to find the solution to the system of equations, what you're going to do to find x is find the determinant of, so what you have to do is find these three matrices. So you have the D matrix, which is basically your coefficient matrix, and then D sub x. So if you take out the x terms and you put the constant terms in its place, that's the coefficients that you're going to write here. Same thing with dy. Take out the y terms and put the coefficient, the constant terms in for the coefficients. It's easier to look at this with an example. So if we're going to solve a system like 2x plus 5y equals 7 and 5x minus 2y equals negative 3, we're going to have three matrices, A, B, and C. So matrix A is 2, 5, 5, negative 2. Matrix B is going to be 7, 5, negative 3, negative 2. Remember that you're going to take the constants and put them where the x terms were to find matrix B. And for matrix C, which is going to be our dy, what we're going to do is take the constants and plug them in where y would be. It looks like this. And so I wrote that A is the d sub y, B is the d sub x, A is just d, B is d sub x, C is d sub y. So if you find the determinant of B divided by the determinant of A, that's what x is equal to. And the determinant of C divided by the determinant of A is what y is equal to. And that's how we get the solutions of negative 1/29 and 41/29. Let me at least show you what that looks like on the calculator. So if you do it on your calculator, it looks like this. So you have, I put these matrices in my calculator, A, B, and C, and then you find the determinant of B divided by the determinant of A. That's your x value. The determinant of C divided by the determinant of A, and that's your y value. It's actually pretty easy. Let's look at one that's a 3 by 3 system. The rules for a 3 by 3 system are exactly the same. It's just finding the determinants is more difficult. You probably want to do this on your calculator. So for example, if you wanted to solve this system, which is a 3 by 4 system, first you're going to set up your D matrix. Remember, D is going to be the determinant of the coefficient matrix. So the coefficients are 1, negative 3, 7, 1, 1, 1, 1, negative 2, and 3. Now, dx, the determinant of the x matrix. Now, how you determine that, remember, is you're going to take the row of x's out, just eliminate those, and where those coefficients would be, put the constant terms. So I have 13, 1, and 4 in that column. The y column and the z column stay the same. Now, for the determinant of the y matrix, what you're going to do is take all the y's out and put the coefficients. For the coefficients, you're going to put this constant, right? The constant. So I put 13, 1, and 4 where y was, and the x's and the z's remain the same. And for dz, we're going to do the same thing, but we're going to substitute for the z column. And then you can do that on your calculator. It's not too difficult. And you'll find that the answers are negative 2, 3/5, and 12/5. All right, good luck. Email me with your questions.